much. So we'll start this concurrent session 130 on electricity demand. So we have, as I understand, 4 presentations, and we will proceed in the order on, that was planned for each of the presentations. So we are going to give around 20 minutes for each presentation and leave like 5 minutes for questions. So I guess we could be starting with the first presentation, which is on committing to flexibility, a field experiment on household demand. And this is going to be presented by Beatrice Roussillon, very similar to my last name, mine in Spanish, and I guess this is in French. From University of Grenoble. So Beatrice, so the floor is yours if you want to start.
Thank you very much. Indeed, our last name are very similar. First, I was wondering whether they were calling me with Juan, which was weird, but no, that's different. Okay, so let me share my screen. Okay, that should be okay. Okay, so this is okay, and then the first page. Okay. So is this correct? Does everybody can see the screen? Yeah. Okay. Yes. Thank you, Margarita. Okay. So yes. Thank you. So this is joint work with Penelope Buckley, Adélaïde Fadhuile, and Llerena, which was conducted at the Grenoble Alpes University. And this is a work which has been multidisciplinary work with the team of the G2 which is an electrical engineer team. And this work was a joint work with that team too. So the motivation of this work is how to study or how to generate indirect flexibility. So the motivation, I think, is quite known here in this conference, but so we can say that the French objective is to turn to 100% renewable energy sources in 2050. And there's 2 solutions, that the storage that you can look at, and there is a demand response program. And in those demand response programs, there is direct flexibility, which you will implement directly on the load of the household, and indirect flexibility when you will send signal, monetary signal or informational signal to induce the flexibility by the occupant. So when we are looking at indirect flexibility, this is the occupant, we will implement it. So we will implement indirect flexibility in the household, which represent in France about 30% of electricity use. So what are economic question? In fact, what we wanted to look at is what are the opportunities for indirect flexibilities, and this was a direct call from the electrical engineer. So they want us to identify who are the flexible consumer, at what time consumer will be the more flexible, and if there were a difference between upward and downward load shedding, which means is there a difference if you ask the consumer to stop consuming during a period of time, or if you ask them to consume during that time? So to increase their consumption when there is, for instance, production in the rates, or to decrease consumption when there is a peak load, for instance. The second question that we wanted to address is, can we generate indirect flexibility thanks to behavioral insight and what it's usually called nudge? So we will try to implement a green nudge to generate that flexibility. And for that, we implement an experiment. So in fact, we will rephrase a bit our question, and instead of taking the side of flexibility, we will translate it into giving incentive to provide a public good. Let me explain that. So when you think about indirect flexibility, most of the time you think about dynamic pricing. But when you look at dynamic pricing, the several studies which has been conducted show that it's difficult to measure exactly the price elasticity, and it seems that the people doesn't feel the marginal effect, which means that if you increase the price, they don't decrease their consumption respectively. It is also the case that dynamic pricing can be perceived as risky for the consumer because they may fail to adapt their consumption to the tariff, and that will result in higher bill. And if they succeed to adapt their consumption to the tariff, that could result also to a severe decrease in comfort. So you have to give them incentive to go for that tariff, whereas they could have some uncertainty how they could manage to adapt their consumption. Indeed, there is two issues with demand flexibility. The first one is that the people don't know what is the energy flexibility efforts. And those energy flexibility efforts are different from the one of energy saving efforts, which are mostly known or more known for the people. So people don't know what to do, what precisely they can do to decrease their consumption in order to be flexible. For instance, the freezer will be one of the electrical appliance we'll look at to decrease the energy, to have some energy saving, whereas it's not at all relevant if you look at energy flexibility. So there is some electrical appliances which are relevant for energy flexibility and which are not for energy saving. The second thing is that the efforts are a bit invisible. So if you look at your monthly bill, you will not know whether it is the result of the effort you have made during the flexible time, or it is because you have failed at other time of the month to save energy or what else. So it's difficult for the people to learn what is efficient in order to be flexible. And this is why dynamic pricing is not enough. You need to add information, at least if you want it to succeed. And this is the recent paper in ITO is going in that sense too. So what we were looking here, it's to go for green nudge because it's not risky for the consumer, and consumer may want to adapt their energy consumption to be more flexible in order to include more renewable energy sources, for instance, or to decrease the consumption, the use of coal-fired power plant. So this was the lead that we follow. And there was already several empirical evidence that green nudge could induce energy conservation efforts. So what we wanted to do is to give incentive to provide a public good, and the public good was the inclusion of the renewable energy sources in the grid and the decrease of the use of the coal-fired plant. How do we do that? So we try to build an incentive design, an incentive mechanism. And this incentive mechanism has three parts. First, information of what the people can do if they want to be flexible. Second, feedback that they can learn what is working and what is not. And we play also an intrinsic motivation. So we induce a commitment from the people to reduce their energy consumption. Let me go a bit deeper in the field experiment. So we conduct that experiment in the area of Grenoble. We have 144 subjects, and we divide it into a control group and a treated group. People receive an indemnity monetary, and that's incentive was mostly to complete a very long survey, and that they will consent to give them the information from their smart meters, that we can access to the information from the smart meters. And the smart meters was Linky. It's the smart meters which is largely deployed in France, that all households almost started to have it. Then we built an incentive mechanism, which is, as I said, start with an information, a commitment, and in feedback. And what we ask the people is to consume at the minimum during the orange alert, which corresponds to peak load in winter during 6 to 8, and to consume at the maximum during the green alert, which is in summer during the afternoon, 12 to 3 o'clock. That's okay, yeah. So let me show you a bit more. So first, we give them an introduction about what is the issue with the renewable introduction, when do we use the coal-fired power, and the problem with the gap between the production and the consumption in the grid. Then we explain them that we are going to send them alerts in the winter during 6 and 8 during peak load period, and in the summer between 12 and 3 during renewable production. And we give them a list of actions that they can follow if they want to be flexible. And we color code those actions in order that they know what was very with maximal impact or with small impact. For instance, what has the maximal impact will be to reload your vehicle battery. So that is enormous impact. So if there is production of solar energy, you should reload it at the time. If we're at the time of peak load, you should not. So that's quite easy, but there's other stuff which was not so obvious for our participants. For instance, like the use of the oven. We explained them that they should use the oven in the afternoon if we are in the production of renewable energy, and not in the evening if we are in the peak load. For the commitment, we make it a three-part. First, we make them think about what they were doing and how they were doing and what electrical appliances they were using during the week. And this was very long and very boring survey, and this was also meant for them to think that they have earned the money that we give to them, and that's all. So the money that we give to them have no impact in the future of our experiment. It was made for that, answering that long survey, which lasts about 1 hour. Then we personalize the list of actions that we give them. For instance, if I don't have an electrical vehicle, well, then this is an action that I cannot commit to. And then we ask them to commit to some of the action that they will do when we send them the alert. And we explain that after each alert, we will send them a reference curve, which is in the blue line, what they would have, what their consumption would have been without us sending an alert. And the red line is what they have really consumed. So the blue line is somehow their counterfactual. So we have a 3 wave of alerts. Once in the first winter, 2019 and 2020. So there was 9 orange alerts, a second wave during the summer, and a third wave during this winter. And so there was 9 alerts in the first wave, 5 alerts in the second wave, and 12 alerts in the third wave. And to be clear, so how it was, so we send them a text message the day before the alert, warning them about the alert. In the same time, we send them all the commitment they have committed to. So we say, well, you say when you were filling up the questionnaire that you will not use that appliances. In the day of the alert, we send them in the morning that this is the day of the alert. And a few days later, we send them a text message saying that they have the reference curves ready and they can see what was the impact of what they have done during the alert. So first inform them about the alert, record the commitment, and after the reference curve. Now the result. First, let's see, we wanted to be sure that our control group and our treated group were similar. And so we look at the socio-demographic characteristic. And it seems that the two groups are perfectly similar, but for the age of the building, which can still matter, but we were quite happy that there is no big difference in between our two groups, beside those age of the building. And if we look at the consumption before the experiment, so before we start the experiment, well, they are very similar. So you have in the blue the control group, the consumption of the control group, and in the green the consumption of the treated group, and you can see that they really resemble the two groups. So our two groups were similar before we implemented our incentive mechanism. Now, and this is a regression confirming that during the time of the alert, the two groups are similar. So we have here no controlling for the temperature, the sun, the hour of the day, and the average consumption per day. We see that the treated group is similar to our control group during the time of the alert. So the orange alert, which is between 6 and 8, and the green alert between 12 and 3. So we were okay. We have two similar groups. During the first wave of alerts, so this is this plot, this figure show you the consumption of the 9 alerts day for the control group and for the treated group. We clearly see during the time of the alert that the treated group has consumed less than the control group. So meaning that our incentive mechanism seems to have worked and that the treated group decreased their consumption during the alert period. So this is joint figures for all the alerts of the first wave. We did the same thing for the green alerts. And we find also significant results, meaning that the treated group, still in green here in the graph, is consuming more than the control group during the period of the day when we sent the green alerts. So people really intend to increase their consumption when we send them the green alerts. And for the second wave, we also have a decrease in consumption of the treated group. So the orange alerts, we call it in winter. So it was this winter. So we just ended up having the result. We made 12 alerts. And in those 12 alerts, we have that the treated group consumes significantly less than the control group during the orange periods. If we look at the regression, so controlling for fixed effect and for controlling for the hour of the alert, the sun, and the temperature, the daily temperature. If we only look at the treated, we see that for the first orange alert, we have a decrease of almost 19% compared to the control group. In the green alert, we have an increase of 10% compared to the control group. And for the second wave of the orange alert, we have a decrease of 12% compared to the control group. Now we have some SM text message issue. This means that sometimes our telephone provider didn't succeed to send the text message, or our participant didn't receive some of the text message. So we can monitor, we have a monitoring for that. But that means that sometimes the people didn't receive the text message. So if we control for that, our effects are increasing, meaning that if we control for the fact that the people have received their text message, we have an impact for the first wave of a 20% decrease, of the green wave of 11% increase, and of the second orange wave of 13%. Okay, so now if we compare the people by themselves, if the question is whether the people decrease their consumption compared or what they used to do during the winter or during the summer. Again, we have a decrease. So we find that our treated group decreased by almost 40% all the alerts. So compared to usual consumption at that time of the day, our treated group consumed 14% less during all the alerts. Orange.
You have 2 minutes more.
Okay, but that's good. And if we look at each alert, it's 17% for the first wave, 11% for the green wave, and 10% for the second orange wave. The conclusion is, so this is, we just finished to get the result. This is why I can only provide you with preliminary results. What we have is orange alert seems to generate 12 to 20% decrease of consumption compared to the control group. And orange alert and green alert seems to result in an increase of consumption to 8 to 10 to 11% compared to the control group. So we have the first conclusion is that our incentive mechanism has worked, and we can use other type of incentive than monetary incentive to induce indirect flexibility. The second thing that we were really interested in is that upward and downward load shifting are both possible. And now what we have struggling with is that the green alerts happened after the lockdown. So we don't know how much the lockdown impact our observation. So it seems that green alert works a little bit less, but in somehow the lockdown may have checking up too. So this is what we're working on, how we can disentangle the impact of the lockdown for our experiments. This is our research agenda. What we want to continue to investigate is the spillover, how the people adapt their consumption, are they moving their consumption during the week, during the day? Do we have habit formation? So people, are they getting better and better at being flexible? Identification of which electrical appliances was used and compare with commitment. So this is what they're looking, the electrical engineer are really looking at, is whether they can, in our load curve, identify which electrical appliances is used and when, and we can link it with the commitment of the people. So we want to do that. I'm not sure if it's possible because it's not very fine granularity, the observation that we have. After that, we will like to do a profile of consumption and isolate the impact of the lockdown. Thank you.
Thanks a lot, Beatrice, for sticking to the time. So we have around 5 minutes for questions. So I wonder if any of the other speakers or some attendee would have a question on this presentation. Yes, Jonas, please.
Yeah, Beatrice, thanks for this nice presentation and the interesting investigation on this. I asked myself, according to the control and the treatment group, if you set the alert and they decide, the control or the treatment group decided to lower the demand, maybe for the washing machine or something like that, maybe they decided, okay, I will wash on the next day. So maybe it's interesting to have a look on, I'm not sure if it's a rebound effect. I'm not sure what it's called, but maybe they will switch just 24 hours later. And then you have a new peak, which you have to inform about. So maybe this is an interesting topic. I don't have an answer, so maybe you discuss it in your group.
Yeah, I think this is totally one of the lead that we want to see, is whether it's postponing the consumption during the day, totally canceling the consumption, or having something which is done in the weekend instead of the day, or the week after, or the day after. So this is something that we want to look at. Yes, I think this is really how we are going to build the flexibility and what will be the consequences for the grid, because some of the alerts could be very close to each other. And so when you are asking an alert each day of the week, how do you do? Could you still be flexible, or is it stopping your flexibility and those kind of questions? And if you want to induce indirect flexibility, but it's better, maybe it's better to say, well, this is a group of people I'm sending on Monday, and this one on Tuesday, and this one on Wednesday. And like that, you can a little bit, have a flattening the consumption.
Okay, thank you very much. Thanks.
Any other question?
Yes, can I?
Please.
Hi, it's Margarita. I was wondering, when you were selecting the participants, did you look at the household income? Because probably people with a higher income would be less price sensitive.
Mm-hmm. Yes, this is a good question. We have we try to have something a bit homogeneous, so we don't have a single person, because we were thinking that they were a bit particular, and we wanted to have at least 2 people in the household. And this is, yes, something we want to investigate, whether the revenue or the income will impact the flexibility, the potential flexibility.
Okay, any other question? If not, I have one, Beatrice. Just, I was looking at the results graphs, and I mean, you can see when you compare the control and the treated groups, they vary in their consumption, even when there are no alerts. So have you probably analyzed if there is any correlation between these periods out of the alerts and the period with alerts?
Yes, you are talking about that little bump in the control group that we can observe in the line. Yeah, this is something we are looking at now, and it's, for now we haven't really find a reason for that bump. So I don't have still a clear explanation. It was not there before, so it happened during the experiment, but we didn't did anything to the control group. So we were wondering, because we have very little, we have 100 subjects. So it could be that few of the control groups starting to be at home in the afternoon, and we have that bump, and they change their behavior during the experiment. So this is something we are looking at in order to explain. But if we control for fixed effect of our people, then we still have our results. So this is in the regression. So that's why the econometrics is also important. So we control for fixed effect for each household, because we don't have a large number of them. Yeah. I don't know if,
okay,
if that was clear enough.
So, okay, good. Okay, thank you very much, Beatrice. We need to move to the next presentation. Let me then move to the next presentation, which is on retail choice impact on consumer behavior. And it will be presented by Margarita Patria from Charles River Associates. So Margarita, the floor is yours.
And to unmute myself, thank you very much. Okay, so can you see the presentation? Okay. Can you see? Yes, okay, good, thank you. Yeah, so this is the study of retail choice and consumer behavior that I did with my colleague, Derya Eryilmaz. We both work at CRA International, and we also both teach economics of energy market at Northeastern University. So we are twice colleagues, and we do research together. So what's the motivation for this study? We are based in the United States, and we are looking at the US market. More specifically, one of my clients is in Pennsylvania, USA. It's a big local utility. As you know, most of electricity is delivered to consumers still, especially in US, by their local utility. Retail choice option was added in some jurisdiction, and it was added in Pennsylvania, the area that we study. And it gives consumers an option to either go with their utility or to switch to alternative retail choice provider. So now consumers have a choice whether to go with utility or somebody else. From the utility state point of view, as well as from the point of view of the retail choice provider, this ability that consumers have to switch creates what they call load uncertainty. And that means, as me utility, I cannot be sure, aside from the weather conditions and other known variables, how much load will I need to provide, because my consumers can switch to a different provider. So that's called load uncertainty. And when we have any kind of uncertainty, there is risk, right? And if there is risk premiums. And this load uncertainty creates some, however small, but still maybe significant risk premiums that are passed to the consumers. So there is a need to for better understanding the switching behavior, when the consumers switch and how. So that leads to the first research question: how do we explain switching behavior? The second question is, when the retail choice was introduced, at least in the United States, it was introduced for the benefit of the consumers. As an economist, you know that it's sometimes hard to define what does benefit really mean. So there are multiple studies that look at retail choice impact on prices, and a lot of them are inconclusive. We are looking at another possible benefit of retail choice, and that's increased price elasticity. The motivation behind is, well, now that consumers are aware that they have a choice, you know, that there are different prices they may be paying, maybe they will be paying more attention to electricity prices, and this may hopefully increase their price elasticity. So that's our second research question. Did introduction of retail choice option have an impact on consumer behavior? Data set. Our data includes, so we have the data separated by customer class. Residential, that's a small customers, as many of you probably know really well. So residential, commercial, they're medium size, small businesses, and there are industrial customers that are large consumers of energy. So residential, commercial, and industrial. We are looking at the two utilities in Pennsylvania, METED, Metropolitan Edison Company, and that will be the focus of this presentation, and Penelec, Pennsylvania Electric Company. We have data currently from 2008 to 2019, and we are actively updating the data set to include 2020 because it was quite a year. The load, the data that we have is aggregated into two groups, and we're looking at the hourly load. That's what we observed, and it's aggregated into groups. First one is the load that is served by utility. It's called non-shopping in the industry. And then there is a load that's served by retail choice provider that's called the shopping load. We do not observe individual consumer behavior. So this is aggregate for all consumers, shopping, non-shopping, but it's broken down by residential, commercial, and industrial. So the load data is hourly. We're not aware of another study that has this kind of data. This data is publicly available, so if there is any interest, I'll be happy to chat about that. We also have customer counts on the utility territories, and that's the number of customers shopping and number of customers non-shopping. That's number of customers served by retail choice and non-shopping, the ones that are staying with the utility. This data is updated quarterly, unfortunately. So we have this mismatch here, but nevertheless, here's our data. Customer class, I just mentioned, residential, commercial, industrial. I want to point out the big differences between those. The consumers here is the size of the load definitely is a lot different in each customer class for different consumers. And if you can imagine, the attention to and knowledge of electricity markets is also different by customer class. When we talk about industrial consumers, they usually have a specific person who is in charge of electricity bills and negotiates contracts and is very aware of everything that's going on. Commercial class, they're a little more aware. There is usually an accounting person. So again, somebody may be looking specifically at this area. And residential, as the previous speaker, also worked with the residential consumption. They may not be as acutely aware of what's going on in the industry and the options that they have. Moreover, in the United States, at least on this Pennsylvania territory, the rates are structured differently for different customer classes. Residential and most of commercial customers, they see fixed price rates. It doesn't matter the hour of the day, doesn't matter, even the month. Their rates are fixed. They will pay fixed electricity rate for the whole year. It may change only once a year. And if they switch, they will be facing a different fixed rate. Industrial customers, on the other hand, they are offered hourly pricing. So the pricing scheme there is they will pay a fee to their energy provider, and then they are facing the market rates. So they are paying the locational marginal prices, often the real-time rates. So they have this option. Some of the commercial classes, and another innovation of the retail choice is that they bring more variance to the rates that residential and commercial customer classes see. So the rates may change, don't have to be fixed annually. They can vary a little more. Regulatory environment is always important. So there was talk about retail choice from 1996 in Pennsylvania, and there were various laws that passed, but it didn't really make an impact. When we start seeing switching is from December of 2008, slightly, where Pennsylvania Public Utility Commission approved a report about what the retail choice consumers should report to them. The first annual report, that's called Retail Electricity Choice Activity Report, was issued by Commission in 2010, and coincidentally, this is in 2010 where we see a start of switching activity from utilities to retail choice providers. We also observe switchbacks. Well-documented switchback from retail choice back to utility occurred around January or after January 2014, where we have there was extreme cold weather in Pennsylvania, in particular in other areas of United States. It was nothing like Texas, but still the prices, the LMPs spiked. They were really high. So some of the consumers that were with the retail choice providers and their rates were somewhat dependent on the real market activity, they saw their bills becoming big all of a sudden. And the utility customers, because the utilities hedge so well, they did not see that. They still had their fixed rate. So we have some switching back. Anyway, all right. Without further ado, here's our first chart. We're looking at industrial customers. Those red dots are percent of customers switched in every given quarter. And the blue line is the aggregate percent of customers switched to retail supplier. So what we see is almost no activity of switching until the first quarter of 2011. And then really quickly in 1, 2, 3 quarters, we observed that almost all of the industrial customers switch to retail choice. So once they become aware, probably, once they were able to, all of the industrial customers switched. And the percent of switched is around 90%. So we see after this a little back and forth, you know, there may be some new industrial customers added, or maybe some business, somebody went out of business. We have no way of controlling for that. So I do not observe this here. Okay, so this is industrial customers very quickly switching. Those are commercial customers on the same territory. We see similar pattern. So what we see is the increase, and we see especially in the beginning, relatively large groups switching in. It's not as quick as with industrial customers. And then we see, and this is going in the negative, switching out, switching in, switching out. So the percent of customers that switch to retail choice provider goes up, not as fast as industrial, but still, you know, it's quite a steep line, and then it levels out, and we see back and forth for commercial customers. And we observe the same patterns in other companies. This is the residential customers. The percentages of switching back is a lot smaller. So overall, it's between 30 to 40% of all residential customers that switched. Again, we see this initial uptick. It's taking a little longer. Then we see switching back to utility, then switching again to retail choice, and then switching back. We do not know, we do not again observe the identities of the customers that switch. Those are numbers on the aggregate. So it's not necessarily the same household that switched back and forth, but we do see that, you know, somebody definitely switched out of this program, and then maybe new consumers joined in, and then we see again switch out. But overall, there is leveling off this percentage of customers that choose retail choice providers. Another thing, well, first of all, with industrial customers, they are all pretty big and they switched so quickly. So we know that they are large companies, and they take the load that they carry is really high. Now looking at, this is commercial shopping. So this is for commercial class, for shopping customers, that means the customers that switch to retail choice providers. This is their average hourly load. So what I'm trying to illustrate here is that the bigger consumers switched first, right? Because the average load, see, as the time goes on, for commercial customers, we see it's going down. So one hypothesis of how to explain this is that the larger size consumers, the one that would be more price sensitive, and more educated about the industry and the options that they have, they switch first, and then the smaller consumers switch in. That's why the average goes down. This is for residential customers. It's, you know, a lot more questionable to, you know, say which one is the hourly load, how big or how small, and we do not observe incomes here. But again, we see somewhat similar pattern that we can say that maybe the consumers with a that consume more energy for their household would have been first to switch, or some portion of them would switch earlier, and then maybe smaller households joined in. But you know, it's hard to say on the aggregate in this on this chart. It's some observations that we're making. Sorry. So now, how to explain it? What can be the intuition behind what we see? And we looked at the classical BAS model. I know it's mostly from marketing, and we had some comments that why don't you look at the models of entry, but we're not looking at this picture from the provider's point of view. We're looking from the consumer's point of view, and the consumers, we can argue, perceive it as something new. Now they have an option. It's almost like a new technology, new option is offered to them. So this is what classic BAS model is dealing with. This is a model of diffusion of a new option, of new information, of something new offered in the market. And, you know, what attracted me here, what attracted us here, they also have this kind of pattern then when you see people joining in and then everything is leveling off. So how it works, a BAS differentiate between the adopters that adopt independently and people who are being influenced by choices of others. So the first group, the one that with L here, with little L here, the first group, they are people who just understand somewhat how the industry works. They make their own independent choices. And when they see a new technology, they may adopt, and this is the choice of their own. And then there is another group of people who are more like followers. It's almost like the adoption of cell phones, right? Of Apple, like my teenagers, they want to have an Apple iPhone because all of their friends have Apple iPhones, right? And there is some anecdotal evidence that, you know, if your neighbor switched to a retail choice provider, then, and they're saying, well, I'm paying so much less for energy now, then you're more likely to have a look at this new technology. So that's
Margarita,
sorry, yes.
2 minutes more.
Okay. It was too much fun. Sorry. All right. So there is a new technology. There are people that adopt on their own, and there are people that follow others. Because we have switching back and forth, and this is what we observe in our data, we think that there are people who are switching on their own, but this coefficient of switching should be the function of prices that they observe. So there are people who will always independently, so there is a proportion of population that have not switched yet. Out of them, there are people who are independent decision makers. They will look at the prices, compare, and make a decision to switch. There is a whole proportion of people that are following others. And then, you know, they hear about this option and they may or may not make a decision to switch, hopefully also based on prices. And then there is also a group that may decide to switch out based on prices. Why 3 different coefficients? Because we're looking at different segment of the population. So we're looking at the segment of population that is still has not switched, and say maybe that's because they haven't learned about this yet. And then we're looking at the population that already has switched, that's the last expression here. So we're looking at the segment population that has switched, and it's clear that they do not compare rates at all times. We do not see this following the prices at all, or almost ever, but there may be some portion of them that will compare prices and sometimes decide to switch back and forth. Overall, this kind of model will allow us for more flexibility and will allow us to reconstruct and calibrate exactly what we observe in the data. However, can this be estimated? It's still work in progress. It's very hard to find the data with prices. I did look at IEA data quite recently, and they report the data for both utilities and consumer choice and retail choice provider monthly, but it doesn't seem like it is a very good data. It just didn't, it doesn't allow for this kind of analysis. So this still work in progress. And really quickly, did the consumer behavior change? Only industrial customers look at hourly prices. So we are just saying, all right, so in industrial customers, they have option to look at the hourly prices, and their bill depends on the hourly prices. Did the reform and this ability to switch to retail choice provider, did this impact their price elasticity? And just the usual demand equation, only we have a term here, post-retail reform. And it seems that at least for in MedEd, they did become a little more price elastic. And we can only say this for industrial customers based on data. All right, so with that, I will conclude.
A lot, Margarita. So there is already a comment or question by Hali Lasme. Can you possibly speak out your question?
No, sorry, I didn't have really a question, but I did wanted to make an observation because I manage energy assistance programs in Delaware. Mm-hmm. So right next to Pennsylvania.
Yeah.
And I kind of know we have a lot of troubles with these electric switchers and how the switching works and third parties and those. So I was trying to make a comment. You were trying to wonder why low income clients or the residential clients behave like that. So that's one of the reasons why they behave like that, is because residential customers have to sign a third-party contract, and usually it's for longer. They can't really switch. There is no such thing like you can switch like the industrial section, commercial section can. And they have to pay a penalty, which often they cannot afford to get out of contract. So they have to turn to utility commission or public advocate to help them to get out of the contract, which they might be able to help or not. It depends. So they're stuck there until the contract is over.
Interesting. Thank you so much for this comment. I will check what's going on in Pennsylvania as well. I wouldn't be surprised if it's the same. I know they had a big push of, I know at first they had a huge push for having the retail choice in Pennsylvania, but then they had just as big of a push to allow consumers to get out of it. So we do see some switch back and forth, but it's really interesting to know that it's not that easy. Thank you. Thank you for this comment.
It's very complicated process. And I think it would help if those third parties would offer non-flexible rates like they do otherwise. Yes. Because then the client would know that that's my rate. But the issue is mostly they show and tell the client in the beginning that this is your rate, which is always less than the current utility rate. And then as the time goes on, because it's flexible rate, they start increasing it, but then they're already locked into the contract. So that's why that has been around United States, the push to regulate more of those third parties to help the market to be more, diverse. So that's my comment.
Thank you. Thank you very much. Thank you for this.
Okay, we have time for another question. Is there another question? So if not, probably, I mean, Margarita, was, you said that you observed price elasticities for residential customers of retail providers. I wonder if you also differentiate price elasticities for different income levels. Is that relevant, or?
It is. It would be relevant, but we just do not observe this kind of data. We do not observe this. There is a study by Ross where he's looking at EIA data and looking at the average income, but there are very little studies where you look at the individual consumer behavior on a large panel. Like Beatrice, they were trying to look at the panel, however small, of the consumer switching behavior. There are not a lot of data that allows for this. Hopefully the more data sets would be constructed where we have big panels and we can observe individual household behavior through time. Unfortunately, we're bound by data limitations.
Okay, thanks a lot, Margarita. So we move to the next presentation. It's on regional flexibility markets and flexible use of residential heat pumps. Empirical findings from a choice experiment among German households. This presentation will be carried out by Jonas Bender from Institute of Economics, University of Kassel. So Jonas, the floor is yours.
Yeah, thank you very much, Juan, for this kindly introduction. My name is Jonas Bender. I'm a research associate from the University of Kassel. And this is a joint work with Larissa, Fait, and Heike Wetzel, and I have the opportunity and the chance to present regional flexibility markets and flexible use of residential heat pumps, empirical findings from a choice experiment among German households. Though I think it's a common knowledge that we have the energy transition with an increasing share of renewable energies, and thereby the imbalance of energy supply and demand in the regional and in the local electricity grids is growing, especially in Germany, though the demand for flexibility is increasing. And with respect to the electrification in the heating sector, households could provide flexibility through flexibility contracts, a new form of contracts. Though households or provider of such flexibility could contribute to grid balancing. And because participation is so important, we ask ourselves, how does contract design influence the preferences for flexibility contracts? And how do different information treatments affect the willingness to provide flexibility in general? So therefore, we have a deeper look into the literature, and we found some hints of the contract design. It was in the area of demand response, demand management, flexibility markets, flexibility contracts, or dynamic tariffs. And there are three aspects which I want to present. That there's a monetary aspect, is a compensation, like a fixed or transaction-based payment seems to be a preference of households. Then the controllability and the distribution of information, and the usage implication and discomfort, like am I able to switch on or off my heating, or which person has the control about it. Furthermore, we found other influences on the choice of flexibility contracts, like socio-demographic variables and attitudes, like household income, or the age. Furthermore, we find out the environmental consciousness and the affinity to technology, which drives towards choosing a contract, a new form of a contract. With respect to the second research question about the role of information, we decided to look more detailed in literature about choice experiment and in the context of energy demand and efficiency. And we found, especially in Engler et al. 2019, these are colleagues from the University of Kassel, they investigated the role of environmental priming on green preferences. As well, the authors Newell and Siakamaki investigated different economic informations, and Plage et al. And Lang et al. Investigated the role of efficiency label, Lang et al., for example, for investments in heating appliance. Interesting, Filippini et al., they investigated qualitative information, so they checked choice experiments or the choice probability by treatments of qualitative information like text-based information or photographs. So that's interesting. And combining these literature, we decided to use information treatments which could increase the provision of flexibility, and we transformed it into treatment or information text that a certain choice of flexibility contract could either contribute to environmental protection or could contribute to reduction of grid expansion needs. So these are the first literatures, and for our method and data, we conducted a survey. This was conducted by our own last year from January to May. And we asked customers of a distribution grid operator who already own a renewable power plant. These are the EEG customers. And at all, we have a sample of 585 German adults. And in the questionnaire, we consisted some social demographic characteristics, some environmental attitudes and economic preferences, and which is the core of the survey is a stated choice experiment and the information treatments I presented before. And on the next slide, I will present the stated choice experiment. This is a choice situation, a hypothetical choice situation, and we transformed it to flexibility contracts. We pointed out 3 hypothetical contracts, and the option that you do not have to choose option is called no choice option. And each contract is defined by 5 attributes, and these attributes varied randomly by 5 levels. So because we have a high combination or a high amount of combination or possible combinations, we decided to use a fractional factorial design. So we generated 60 choice sets, bundled them in 10 blocks, and by using the survey, we asked each respondent to answer 6 choice sets. With respect to the second research question, we separated the group or the sample in 3 groups. There was a neutral group which got no additional information. Then we have the second group which got treatment information about the environmental protection, and the third group was the group which got the additional information about the grid benefits. Yeah, in the next step, we will have a closer look to the attribute. We decided to check. We used the 5 attributes, the monthly compensation with the euros, the amount of euros. We decided to check the maximum number of flexibility calls per month. It's close to a discomfort. Then the guaranteed minimum room temperature in case of a flexibility call. So we guaranteed the minimum room temperature, especially, or for example, from 19 degrees. The fourth one was the frequency of information provision about the occurred flexibility calls. So there was information provided online or via app at any time for the certain contract, or weekly, monthly, annually, or maybe possible annual billing. The last one was a personal influence. This was one of the literature we found that there's a preference for controllability, so we gave them the opportunity to do that. No intervention on flexibility calls is already mentioned, but we decided to include 4 more, 2 hours per day. They can interrupt 2 hours per day They can change it monthly or 4 hours. This is one group, maybe the time slot. And the other 2 attributes are prevention of 1 flexibility call per month, or we increase the amount, the number of prevention in 5. Yeah. Looking maybe in an exemplary choice set, we asked them, please choose the option that is best for you. And as mentioned before, you can see the option 1, the option 2, and the option 3. And the option, I do not want to choose any of these options. And then you can have a look on the different attributes and can decide whether you want to use a flexibility or not, and then decide which flexibility contract you prefer. Yeah. And the next step, I will go ahead with econometric analysis and results. And we use the mixed logit and latent class membership models. We are on an early stage of estimation, so I'm happy to present it here at the IAEE online. And we decided for the dependent variable the choice between different hypothetical flexibility contracts and the no choice option. For the estimation, we fixed the monthly compensation, especially for the mixed logit. And the other parameters are random designed or goes in the model randomly instead of the monthly compensation. There we will have it in a random way. We conducted the mixed logit estimation for the control group. You see it in the top of the table, the climate group and the grid group with the mean and standard deviation. You see in the bottom the number of observations. The groups are nearly the same, 194 up to 196 or 195. We got a lot of stars that indicate that we found significant effects, or that indicates for significant effects. And on the next slide, I sum up some basic information, so I think it's easier. The estimates at all are in line with expectation from the literature. There are significant standard deviations that indicate heterogeneity in preferences. And we found positive and negative effect on the utility. So positive is in line, the increasing monthly compensation has a positive effect on estimated utility, and an increase in personal influence on the interruption of flexibility calls has a positive effect on estimated utility too. Be aware, the personal influence on the interruption of flexibility calls is a categorical variable, so we have to compare it to a base category, and this was a no intervention. And we found a 3 negative effect on estimated utility. This was a decreasing minimum room temperature, the increasing number of flexibility calls per month, and a decreasing frequency of information provision. As well, I mentioned before, these are categorical variables, so we have to compare to the minimum room temperature, 21 degrees, or compare to the highest or the best frequency online or via app at any time. Yeah, these are the parameter estimates as well. To compare it a little bit better, we decided to use estimation for willingness to pay. And this you will see on the next slide. And please have a look on the left plot in the top, the guaranteed minimum room temperature. Have in your mind, we compare it to temperature, the minimum room temperature of 21 degrees. So we plotted the control group, the climate group, and the grid group with different levels of 20, 19, 18, and 17 degrees. Now, and compared to 21 degrees, if the contract design guarantees a minimum room temperature from 17 degrees, additional monthly compensation of about 42 euros is needed. This is the interpretation form, and you can see that that in increasing discomfort, I would say, goes ahead with a higher compensation. And this is equal to the climate and the grid group, but in the amount, you can see that the climate and the grid group are a little bit lower than the control group. Yeah, this indication, or this you can see at the frequency of provision of information. Have it in your mind. It is about it's compared to the provision of information which was online or via app. Now you see overall that a lower frequency of information provision goes in line with a higher compensation expectation of households. And I find it interesting that especially the annually or the heating bill indicates a higher compensation than the other ones. So maybe if I'm a grid operator and I want to use contract design, I would provide, or I should provide, a high frequency of information provision to deal with a low compensation rate. Looking on the third table, the personal influence on interruption, you see that it is a negative one. So I think it's close to, if you have more influence on interruption, you are closer to a regular form of electricity contract. So you are closer to it and you need lower compensation. And you see it in first that the climate group has a high compensation reduction. And I think that's interesting that you have, by the regularly or by the time slot interruption possibilities, you have a higher reduction than by the prevention options. So this maybe goes aligned with the comfort aspect, that it's more comfortable for the households to say, okay, 2 hours or 4 hours a day. Yeah, and the last attribute, the maximum number of calls per month. This is a numerical metric variable. So if the contract or if the flexible contract adds 1 flexibility call, the compensation amount increases by 20 cents. So this is, I think, more an attribute which is for calculation for the grid operator and not as useful for the households. So after we checked the first research question about attributes, about the levels, about the preferences, about the willingness to pay, and we compared each other, we will now check the second research question, what's about the role of information and the information treatment. And therefore, we go on the next slide. And we see, it's stated on the right side, that we have more than a half of decision where the flexibility contract was chosen, but we have 45% of all decisions. There was no choice option. It was chosen, so we have a group of providers and non-providers. By this, nearly a quarter of the respondents were never willing to provide flexibility, whereas 13% of the respondents were willing to provide flexibility. Now, this indicates for this heterogeneity. Looking on the left side, you see the control group, the climate group, and the grid group with the frequency of choosing one of the 3 flexibility contracts. And as stated in the top, you see the p-values, which indicate that additional information on the climate and grid benefits seems to positively influence the provision of flexibility, especially by heat pumps in our survey. So compared the climate group to control group, or the grid to control group, and the climate group to grid group. Yeah. So after we check this, we estimated a latent class model to analyze more deeper the providers and the non-providers. To analyze it more deeper, it looks nearly the same. We have the control group, the climate group, and the grid group, but we divided the control group into 2 classes. providers and non-provided, as well as the climate and the grid group. And as you see, a lot of stars, as it was in the estimation before. As a summary, the estimates in a short way. We can see it's an early stage of estimation that the estimates are in line with the mixed logit estimates, and across all groups, the largest group are the providers, and the higher number of providers is especially in the climate and in the grid group. So with respect to one certain attribute, the monthly compensation, we see that the providers seem to have a lower compensation expectation than non-providers, which is interesting maybe for the grid operators who should aim their contracts maybe at first for the providers because it's more cheaper. So after this, I will conclude our findings. We found out that households are likely to provide flexibility, but there is a certain group or a certain amount of decision where the no choice option was chosen, and 23% of all respondents were never willing to provide flexibility and choose in all decisions the no choice option. So there's a reluctance to flexibility, maybe due to the hypothetical bias or to it's too new. Yeah, there are some restrictions on the use and comfort. They are most important for the decisions on flexibility contracts. The service attributes as information, flexibility calls, and intervention options are secondary. And we found out that additional information on environmental and grid benefits positively influence the general willingness to provide flexibility. And this seems to decrease the requested monthly payment of the households. Yeah, our next steps is to look more deeper into the question who is willing to provide flexibility. We want to conduct further estimation of latent class and willingness to pay estimates for provider and the non-providers. And we want to include socio-demographic characteristics, environmental attitudes, and economic preferences. So thank you very much for listening, and I'm happy to answer your questions. Thanks.
Thanks a lot, Jonas, for sticking so well to the time, 20-minute time limit. So we have time for questions. I wonder if anyone have a question. Yes, Beatrice, please.
So thank you very much, Jonas, for your presentation. It was very clear and very interesting. So I have maybe one, maybe two questions. The first question is, do you have the bill information about your participant? For instance, can you calculate, for instance, what means in decrease the monetary reward you're offering regarding their bill? Because I'm just wondering whether 15 euro decrease is not the same if you have, I don't know, 1,000 bill or if you have 200 bill.
Okay, so we have, we ask in our survey as well the socioeconomic attributes. So we are able to check for the income, for the household income, when maybe that is one part of your question, that we can deal with the amount, if it's a high compensation rate for the household or not.
Okay.
So maybe we can this, and maybe you can repeat this, the other part of your question again.
No, but that was the question. Yes.
Okay.
I was wondering whether you have the characteristic of the output option, in fact. So if you have, for instance, the temperature in the room and the bill and what is the services that they already have, can you describe the output option for your participants?
The output option. I'm not sure if I understand your question correctly.
The opt-out. Sorry,
yeah,
opt-out.
Okay.
Can you describe the opt-out option for each of your participants? Do you have that information?
Okay. Yeah, we actually check this. So maybe they have a different room temperature, or maybe this is your question. What is the baseline of the no choice option? Yeah, of course. Yeah, we are actually we are looking at the data. Yeah, and we will check it. Yeah.
Or maybe I can add something to this, Jonas. I think we also asked them how much is their monthly payment for electricity.
Oh yeah, of course.
We also asked, so yes, we know what they are paying, or at least if they told us. Many people don't know in Germany how much they are paying. Like the regular tariff in Germany for a household is similar than like in the US. So you have a fixed rate, you have a monthly bill, but only once a year you get the whole bill about the whole consumption over the year. So you pay like every month you pay like 50 euros or something. This is what some people know, not all. And at the end of 1 year, you get the total bill, and you either have to pay a little bit more after this or a little bit less. And that's a standard tariff. So no dynamic tariffs, or not a lot of dynamic tariffs are around in Germany at the moment.
Okay. And would you say that could you estimate whether people would even value the fact that they delegate the optimization of their heater pump? Like, this is something you are looking for because you don't want to do it, and you will appreciate if someone is just managing it for you instead. Because I see you seen only in you need to be compensated, but it could be also that it's a valuable services. I don't know. Do you have some?
Okay. I mean, the idea is that, or at least when people have a heat pump at the moment, they usually use a day and night tariff. So that's one kind of dynamic in this setting. But at the moment, there's nobody that is actually steering your heat pump or something. We haven't actually asked the people or the respondents whether they would allow somebody else to steer their heat pump, but so we did not directly ask, but it's the background idea of the whole setting, right? So if you vote for a flexibility contract, then somebody is controlling your heat pump, and then if somebody's using the flexibility, so the grid operator usually, or even an aggregator, then your room temperature will decrease depending on how long the heat pump is, for example, stopped, right? So this was given as a text to the respondents that this is going to happen. Is this answering your question?
Okay, well, yes, I think this is good. Okay.
Thanks
thank you
for the question.
Go ahead, Jonas. Jonas, you were going to say something else? Or?
Yeah, I just want to say thank you for the question, and Heike, thank you for contributing the answer.
Okay, I was also going to say the same thing. Thank you, Jonas and Heike, for your responses. We need to move to the last presentation of this session. It's on dynamics in New Zealand's direct unembodied energy consumption between 2006, 2007, and 2012 and 2013. And it's going to be presented by Juan from the Energy Center of the University of Auckland. So the floor is yours.
Can you hear me?
Yes.
Okay. Hi. Hello, everybody. I'm very pleased to present my research here. So it's very hard for me to keep me awake at this time because now it's about 5 o'clock, I think, in the morning. So okay. So this research is to examine New Zealand's energy consumption and energy-related greenhouse gas emissions. So I will focus on the second part, energy-related greenhouse gas emissions, since the first part, energy consumption, this research work has been published. So this is a joint work with Fengtao Guang, Yiqing Wang, and Professor Beatrice. So in this presentation, I will start with a brief background introduction and talk about literature, introduce my research questions, and present models and the results. Finally, I will draw conclusions and provide policy recommendations. So let's look at the New Zealand context. So New Zealand government's target is to achieve net zero carbon by 2050. Energy sector accounts for about 40% of total greenhouse gas emissions. So to achieve government's target, we need to have a better understand New Zealand energy related emissions profile. So, and this is why I carry on this study to examine factors that influence energy consumption. So the red graph presents energy consumption, energy-related greenhouse gas emissions, and also total output for these two periods, for these 2 years. So we can see the energy consumption reduced during the period. Correspondingly, and we see emissions also reduced. But we can see the expanding total output for this period. So the study attempts to answer the following research questions. What drives changes in energy consumption and energy-related CO2 emission, equivalent emissions? So what factor has increased or decreased energy consumption and related emissions? And do those factors that influence energy consumption and emissions vary across sectors? So what key sectors should we pay attention to when designing energy and climate policies? So answers to those questions will provide insights for planning to transit away from fossil fuels. So this study used a combination of environmental extended input and output analysis and structural decomposition analysis. So for EEIO analysis has been widely applied in the literature to examine patterns of energy consumption, carbon emissions, and evaluate the consequence of energy policy. And structural decomposition analysis is based on the input-output analysis, but it limited to the availability of input and output tables. So this research requires 3 types of data. So in this research, we have 2 input-output tables. That's national accounts input-output tables provided by Statistics New Zealand. And also we have energy consumption data released from Ministry for Environment, and also energy-related greenhouse gas emissions data. So this flow chart presents the methodology framework. We use the following steps to carry out the analysis. So first, we integrate 106 sectors into 15 sectors to matching energy consumption and the CO2 emissions data. And then next step, we represent the economy and based on the input-output tables with energy consumption and CO2 emissions data. So finally, we use SDA analysis to examine driving factors and trace the energy and emissions flow. So this is an input-output table. So the input-output table and input-output analysis was first proposed by Leon Tief. So input-output tables can illustrate monetary or physical transfers, and so the interdependence among production and consumption activities during a given period of time. So the role reflects the distribution, direction, and value composition of the sector's output. So this is the total output produced by sector 1. So, and how to distribute those amounts to as an intermediate use for sector 1, for sector 2, and for sector N. And then the rest is meet to the demand by final demand category and used by the household, used by the government, used by the firm, and used by the foreigner. And the column, the column here is represents to produce X1 input, the output. So for sector 1 needs those kind of inputs is produced by different sectors. So in this way, this input-output tables can enable the calculation of direct and indirect emissions produced by different economic sector and different final demand. So we identify five factors that will contribute to changes in energy-related emissions. So we have carbon intensity factor, we have production factor, we have demand structure and the factor. We also have consumption volume effect factor. It is derived by GDP per capita, and we have the population effects. So all those 5 factors is going to influence the energy-related emissions. So, and this is the equations and how to decompose these 5 factors. So this is this figure shows direct and indirect energy-related CO2 equivalent emissions by sector for this 2 years period. And I use this 2 years because in New Zealand, financial year ends in March. And so each input-output table is going to across 2 years. So we see the red color represents the direct energy-related emissions. The blue color represents the indirect emissions. We found this is the largest emissions is from the transport sector for indirect and both direct and indirect emissions. We also found energy emissions from electricity generation also contributes to a big amount. However, when we look at the indirect energy-related CO2 emissions, this indirect energy-related emissions refers to emissions associated with intermediate inputs used in the production process. And direct energy-related emissions, that is the emissions directly produced when you when producing goods and services. So we see a little bit different pattern from this figure. Now let's look at the decomposition results at the national level. We have 5 factors. 2 factors we see contribute to increase energy-related emissions. This is population contributes, population effects contribute to about 5%. and also per capita consumption volume effects, that is GDP per capita, and contributes to about 2%. So also we have 3 factors contribute to a reduction in energy consumption. Among them, carbon intensity contributes to the biggest amount. This is 8%. So this is results at a sector level. We can see this is the yellow color is represents population effects. So population effects and also the pink color is consumption volume effects. All contribute to increasing energy-related emissions as expected. So, and however, the other 3 effects, emission intensity, production structure, and demand structure contribute to the changes in emissions and vary by sectors. So for energy generation and also transport, we see they are the key sectors we need to focus on when we design the policies. For example, for an energy generation sector, carbon intensity effects contributes to a significant reduction in energy-related emissions. However, for transport, we didn't see carbon intensity effects play a very minor role here. But we see production and also demand structure contributes to a reduction in related emissions. So this is carbon intensity by sectors for this 2 years period. So for these 2 years, we see the carbon intensity, and we have the top 3 sectors, they have the larger carbon intensity. So the carbon intensity is emissions released when produced 1 unit output. So that's either they produce the energy and they produce the output using more energy, and or they use the dirty energy if we have the relatively larger carbon intensity. So now from the demand perspective, when we see the energy, how to distribute it. So for this graph, we see the consumption. This is the consumed by the consumer, and consumed by firm, consumed by government, consumed by a foreigner. We see these 2 pillars contribute to they consume. They are the big energy consumer. So correspondingly, we see the similar pattern for energy-related greenhouse gas emissions. So this figure shows carbon intensity by final demand category. So what does this figure tell us? So these results indicate that if we transfer expose and valued at $1 million into private consumption or government or private consumption, and the emissions can be reduced by a different amount. So this is the composite results by final demand category at the sector level. So we can see private consumption and associate a big reduction for the electricity generation sector and also commercial and residential sector. And however, exports and contributes and the positive effects to impact on energy-related emissions, especially as for food processing, beverage, and tobacco sector. So now let's conclude. Overall, carbon intensity was the most crucial factor in curbing New Zealand's emissions. Reducing carbon intensity has been proven to be the most effective way to restrict the growth of energy-related greenhouse gas emissions. Changes in the structure of production and demand contributed to a decline in energy-related greenhouse gas emissions. Changes in population and consumption volume increased emissions. And private consumption and transport was the main sources of energy-related greenhouse gas emissions. So we also found two key sectors that they are energy generation and transport, and the key sector we should put the policy focus on for reducing energy-related emissions. So this conclusion highlights policy implications for reshaping New Zealand emissions profile. When designing energy and climate policy, policies should be designed with a focus on promoting renewable energy. There are several ongoing projects to explore renewable energy potentials in New Zealand, such as New Zealand battery project, some hydro projects, government funded some, and first some investigation is going on right now. So I also, you might be able to think about the offshore wind potential and coupled with hydro production also provide good opportunity for New Zealand because New Zealand has a good wind resources. And the second, we need to decarbonize transport sector. So maybe we should think about electrification of transport. We need to phase out fossil fuel vehicles and increase low carbon transport alternatives. So we also need to increase incentives for EV purchasers. Also need to have some smart integrated traffic system and also strict emissions standards for this sector to reduce emissions. And then while we also should not ignore other sectors, and for example, we found changes in carbon intensity drive emissions up for chemicals and mineral and food processing, beverage and tobacco sectors. So electrification of those sectors may be the solution to reduce emissions, such as we need to replace coal gas boiler with electric boilers, adoption of the efficient production process and replacement of outdated machinery equipment. All those actions could help to reduce emissions because private consumption and export was the main sources of indirect and related emissions policy around improving energy utilization in private consumption and optimizing and exports contributes to achieving emissions reduction targets. So this slide lists the reference I used in this presentation. So that's bring me to the end of my presentation. And thank you for your time and listening.
Thank you very much, Lee. Thank you very much for sticking to the time limit. So now I would ask if there is any question on this presentation. Heike, please.
Yeah. Thank you very much for the presentation. Actually, I have a question on the definition of the different factors that influence the energy consumption and CO2 emissions by the sector. So when I looked at the slide where you had the factors and how much they influence the sector, I was wondering, for example, what is the difference between emission intensity and production structure? Like I saw this for the energy sector, and I was wondering what's measured by these two factors. What's the difference?
This is very good questions. So Leontief and that matrix basically represents, an production structure. This is basically when you produce the output, you need to have the inputs such as labor, capital, and intermediates inputs. So all those changes will affect the energy consumption and then also affect the energy-related emissions. So this Leontief matrix can capture this production profile. And the other factor, and can you tell me what's the other factor you asked? Sorry.
It was the difference between, like, for example, for the energy sector, the difference between emission intensity and production structure. Because I mean, when I take the production structure and I would interpret the production structure in the energy sector, for example, a switch from coal to gas or a switch from coal to renewables. Am I right or am I not?
No. And I think, this is a very good question. I think maybe, carbon intensity here is defined very simply. We just, use the carbon released, and that's carbon released for this sector divided by the total output. So that is how to define the carbon intensity. That's basically per unit output you produced and how many emissions you released.
Okay.
So this is carbon intensity. So in our research. And for the production structure, that indicates so the inputs profile. So the inputs, such as we have if you produce inputs, you need to have the capital, you need to have the equipment, you need to have the intermediate goods, then you also need to have the labor. So all those inputs adding up together, you can produce the output. Okay. So the structural change in all the inputs, we call the changes in the production structure.
Okay, thanks.
So however, the demand structure tells you the different story, because think about the economy, we have four main final demand components. This is consumer, this is firm, this is government, this is foreigner. So all those four components, is adding up together. This is the final demand. So there's a final demand, because for the final demand for all the products, for each sector, they produce the products and we evaluate. And for example, sector one, this is agriculture. So the total demand by the agriculture divided by the total final demand. So this is the we have these numbers, and then we calculate this percentage for the next sector, and then following on. So changes this demand, the demand by the sectors, changes the demand produced goods services produced by this sector changes also affect the emissions. So this we call the demand structure change.
Okay.
Yeah. Thanks. I hope I have answered your question.
Yeah.
Okay. Is there any other question? If not, I have a couple of questions, just very specific. So when you talk about transportation, do you refer both to private and public transportation in New Zealand?
Yeah.
Both.
Yes.
There is no differentiation.
For the transport, because we have 106 sectors. So when we do this, and analysis, we want to make a simplified. We can't do 106. So we just aggregate them together and merge to 15 sectors.
I see. Okay. Yeah. And the other question is, would there, when you talk about policy recommendations, would there be a case for promoted distributed generation in New Zealand, like the use of photovoltaic solar panels at the residential level? Would that make a difference or not?
Oh, okay, this is for, okay. I think it depends, in New Zealand, we don't have much solar installation right now. And because solar resource in New Zealand is not very ideal. And also for the consumers, we still think, and this is a little bit expensive, But for the wind, I think it's going to be, it's the future in New Zealand, So because wind resource is about, the capacity factor is around 37%. So, and now the government, I think there are some ongoing investigation to investigate the offshore wind. Yeah. And also the government have some, and plan for the green hydrogen. So at the Taranaki area, because for that area, the government is already and don't want them to further to do the oil and gas extractions activities. So they need to replace with some new technology. So they look at the hydrogen potential. Yeah.
Okay. Okay, thank you very much. So, well, I think we have to stop now. Thank you very much for this so much interesting session with contributions from at least 3 continents in different time zones. So it was a pleasure. And then, well, have a nice rest of the day and good luck with your research.
Yeah, thanks everyone for joining the session. Apologies, Dr. Wen, this was really too early for you, 5 a.m. So we apologize for that. Now in the international nature of the conference. So I do hope we all have, so good morning, good afternoon, good evening to everybody, wherever you are, and enjoy the rest of your day. Bye for now.
Goodbye.
Bye. Thank you.
Thanks.
Thanks.
Bye. Thank you. Now I wake up.